they come and go. This is one that I've had forever, I know.
Hello and welcome to class. In today's lesson we'll look at acid and salt of carbon. Remember in our last lesson we looked at carbon or oxides of carbon. We said carbon form two major oxides, which are carbon 4 oxide and carbon 2 oxide. Today we want to look at acid of carbon and the salts of what? Carbon. Now when carbon 4 oxide is dissolved in water, remember in our last class we said it forms what? A weak acid, which is a dibasic or diprotic acid called carbonic acid or triocarbonate 4 acid. Okay, now the triocarbonate 4 acid exists as mainly liquid, although there's a new research that NASA came up with that they have been able to isolate it as what? A solid. This is the structure. That's the central carbon bonded to 3 oxygen, one of which is a double bond and the other 2 are what? Single bond. And the other 2 single bonded oxygen are now bonded to what? Hydrogen. Now the acid is formed as a result of what? The dissolution of what? Carbon 4 oxide in water. Take note that it is a weak acid, and you can see its dissociation here. It first of all dissociates partially to release hydrogen ion before it now dissociates completely to release the other hydrogen to form the triocarbonate 4 ion. Okay, now in the absence of let's say a more basic condition, is likely going to form what we call a bicarbonate ion, as you can see in this reaction. You see the triocarbonate 4 ion bonded with another one to form what we call the bicarbonate what? Ion, which of course are bonded to metallic metal to form the triocarbonate 4 salt. Okay, now triocarbonate 4 salts are salts of metal or ammonium radical that are formed when all the hydrogen or partial replacement of the hydrogen in the triocarbonate 4 acid is what? Achieved. So as a result of this bonding, we have 2 main categories of salt formed during this process. The first one is called the normal triocarbonate 4 salt, while the second one is called the acidic or the hydrogen triocarbonate 4 salt. Now the normal triocarbonate 4 salt are formed because of complete replacement of the what? Diprotic hydrogen, or the 2 hydrogen in the diprotic acid, is it not? And it is prepared in the laboratory by the bubbling of carbon 4 oxide into an alkali of the corresponding metal. Like here I use potassium hydroxide, it can be sodium hydroxide, it can be calcium hydroxide. When you do that, it will result to the formation of what? The corresponding triocarbonate 4 salt. Here is potassium triocarbonate 4 salt with the release of what? Water. We can also prepare it by heating the hydrogen triocarbonate 4 salt. Now you must take note that all hydrogen triocarbonate 4 salt decompose on heating to release carbon 4 oxide in the process. In fact, this is a way we use to test for triocarbonate 4 carbonate ion in the laboratory. Okay, now of all the triocarbonate 4 salts, only those of the alkali metal and ammonium triocarbonate 4 are soluble. The rest are what? Insoluble. Okay, here sodium carbonate dissolved in water to produce sodium hydroxide and what? Water. Preparation of the insoluble triocarbonate 4. Now the insoluble triocarbonate 4 are prepared by a method of precipitation. We use either sodium triocarbonate 4 or sodium hydrogen triocarbonate 4 to precipitate the corresponding what? Metallic salt. Now it is important to note that when we want to prepare those insoluble trioxocarbonate 4 of metals that are below hydrogen in the electrochemical series, we make use of the sodium hydrogen trioxocarbonate 4 because of the reactivity. Okay, it will be precipitating the same substance with the hydroxide of the metal, which is not what we want. All right, now in the equation you can see both calcium and what, silver, being precipitated as what, their corresponding what, carbonate from their what, metallic what, salt. Okay, make sure you note these equations. Now aluminum trioxocarbonate 4 do not exist in reality, okay, because of the high reactivity of aluminum itself and other ambient conditions. Precipitation of these aluminum trioxocarbonate 4 substances usually do not exist. Instead, what we get is aluminum hydroxide when precipitated with the corresponding sodium carbonate. Properties of the trioxocarbonate 4 salt. The trioxocarbonate 4 salt are insoluble with exception of the trioxocarbonate 4 of the alkali metals and that of ammonium trioxocarbonate. Okay, take note, the others are what, insoluble. All right, with the exception of sodium, potassium and barium carbonate, all the other trioxocarbonate 4 including hydrogen trioxocarbonate 4, all they usually what, decompose on heating. Okay, they usually decompose on heating, but those of potassium carbonate, sodium carbonate and barium carbonate do not decompose on what, heating. Reaction with acids. Okay, all trioxocarbonate 4 react with what, dilute acid to form carbon 4 oxide, water and salt. Okay, as you can see there, sodium carbonate combining with what, tetrasulfate 6 acid to form sodium sulfate plus water plus carbon 4 oxide. Then I have zinc carbonate combining with what, HCl to form zinc chloride plus carbon 4 oxide plus what, water. Let's now look at hydrogen trioxocarbonate 4. These are the salt form when only one hydrogen of carbonic acid, okay, is replaced by a metallic ion or ammonium what, radical. Take note of that. Okay, they are actually formed when, like in this case you can see here. Now they are prepared in the laboratory by passing carbon 4 oxide through either the alkali or the corresponding trioxocarbonate, as you can see there. Okay, all hydrogen trioxocarbonate 4 salt decompose on what, heating. Okay, they decompose on heating to release what, carbon 4 oxide. Yes, the hydrogen trioxocarbonate of sodium, potassium and magnesium can be isolated. Okay, while that of calcium is the cause of hardness of what, water. You should know that. Of course, the hardness of water is caused by what, calcium and magnesium what, carbonate, as you can see here. Okay, now the water cycle simply shows how carbon 4 oxide what, move around. Okay, to explain the processes that uses carbon 4 oxide and the process that generates carbon 4 oxide. Generally, the process that generates carbon 4 oxide is mainly respiration. Okay, where glucose or starch is broken down, okay, into simpler molecules with release of what, carbon 4 oxide. Why the process that make use of this carbon 4 oxide is what, photosynthesis. Okay, for plants and other green or organisms. Okay, that now brings us to the end of today's lesson. Remember to do your other activities in this lesson I'll see you soon. Stay safe.